All right, so these three warm-up problems, you're supposed to graph them. Folks, if I want to graph a line, what form is it best to be in? Awesome, you guys are already ahead of my fourth period class. Right here it is. Y'all see that in blue? I'm not erasing it. Okay, it's there. We're going to need it a lot. From that, I have to have the y all by itself, correct? Is that happening in number one? No. How do I get the y by itself? How do I bring the 3x over? Everybody following that okay? Everybody staying with Dalton okay? All right, Dalton, you got another step for me? Not by y, by -1. Does everybody see that little negative sign out front there? That is a -1, isn't it? Okay, so we're going to get rid of this. And then Dalton, go ahead and finish it off. What's the final equation? Does anybody have any questions on where any of that came from? -3 divided by -1 is a +3, and 7 divided by -1 is a -7. Where do I begin this line? Does everybody see this -7? Does that happen on the x or on the y? On the y-axis. So 1, 2, 3, 4, 5, 6, 7 would be right about there. Where do I go? To the right. Remember, this is that is +3 over 1, so we're going to go up 3 to the right 1. Up 3 to the right 1. And I told you I want at least 5 points on here. You could give me more. Eventually, you might need to do more with some of the other stuff we'll do after this. But for now, 5 points are good. And again, try and make your line relatively straight. Make sure your points are nice dots on there so I can see them. I was looking at some of your homework when I collected. I can't see some of those dots. Get them on there. Questions for me? No? Okay, let's skip number 2 and let's go over to number 3. Does this look like slope-intercept form? No. The y has to be by itself. How do I get the y by itself? Oh, I'm over at number 3 here. I'm going to skip number 2 for now. I'm going to get rid of the 2x first. What is that new equation? Good. Everybody following? Now, how do I get rid of the -3? Divide by -3. So I now have y equals. Now, folks, what is a negative over a negative? It's a positive. Does 2 divide by 3? It's a decimal, isn't it? Do I want a decimal for slope? No, I want a fraction, so we're going to leave this as 2/3 x. The only time I can have a decimal for slope is if it's a word problem, if it's a real life situation. Now, does this 2 divide by this 3? No, but a negative over a negative is a positive, and we'll just leave that as 2/3. So where should I begin? 2/3. Now, folks, is 2/3 a nice number? No, it's in between, isn't it? So I'm going to start 2/3 on the x or on the y? On the y-axis. And 2/3 would be about right there. How is that for everybody? If my first point is an in-betweener, all the rest of the points should be an in-betweener. Where am I going to go from this? Which way over? To the right. So we're going to go up 2 to the right 3. And you'll notice that every point that I put on here is just a little bit below that line because it's the 2/3 that threw it off. And I'm going to have to go down 2 and back 3 to get my 5th point on there. You guys remember how we can go the opposite direction as well? Yeah? Okay. To get our 5 points on there. And that's number 3. Now, yes. Now, Luke, you were already on the right track for number 2. Can you tell me what you said before to do to number 2? Divide both sides by 4. And what's the new equation? Good. Now, folks, that does not look like slope-intercept form, does it? What's wrong with it? There's no y. It's never going to cross the y-axis. which means which way is it going to go, vertical or horizontal? Vertical. Go to where x is -2. Where is x -2? Right here. And I'm going to draw that line vertical. Those are the easy ones. Super easy. If you know what you're looking at. Everybody doing okay? Ready to move on to our notes for today? Okay, now you should be able to fill in slope-intercept form. Awesome. You should be writing in there y equals mx plus b. Oops, I think I kind of cut it off. It's up top here, isn't it? Now, tell me what the b stands for. And that is always where you begin. Remember me talking about that on Friday? What does the m stand for? The slope. And that's how much it goes up or down by every time. That's the rate of change. We also talked how rate of change is the same as slope. We still following? Okay, so we're going to use this with word problems today. I'm going to read along. You follow. Carla has already written 10 pages of a novel. She plans to write 15 additional pages per month until she is finished. Write an equation to find the total number of pages P written after any number of months M. Now, does everybody see how I'm using P and M instead of X and Y? Yes? Okay. So if I'm going to write this equation, the first thing I want to know is where do we start? What is the B for Carla? Where does she start? She already has 10 written, doesn't she? Is that a positive 10 or a negative 10? So I'm going to have a plus 10 in that B spot for the y-intercept. Is everybody okay? Now, what does she do every time? Does she go up or down every time? She goes up by how many? 15 per month. Does everybody see that? Don't I have a variable for month down here? What is it? So how do I represent that? 15 pages per month. Perfect. 15M. Everybody doing okay? And then that will tell me, that will equal what? Not Y, P in this case. How is everybody doing with my, oh, why is that line on there? How's everybody doing with my equation? Good? I don't know what's going on here. Yeah, let me see if I can do it this way. That's weird. Okay. Anyways, let me put that equation back up there. What was it? This is, yeah. Okay, so now it says I'm supposed to graph it in part B, correct? Where's my first dot? What's my first point? Where do I begin? At 10. Where is 10? Right there. Now, I'm supposed to go up 15, right 1, correct? Well, I have a problem because my lines don't go by 15s, do they? No, they don't. So I can't do that. But what I can do is look down here and see this 1, 2, 3, 4, 5, 6. Those are M's, aren't they? Yes? So I can take that 1 and plug it in for M and find an answer. So grab your calculator. What's the first thing you're going to type in here? Times, plus, which gives you what? 25. So I'm going to go 1 comma 25, which would be right about there. Now what are you going to plug in? 2. And again, we probably don't need our calculator for this. What's 15 times 2? Plus 10. So this is 2 comma 40. Everybody following? How about plugging in a 3? What's 15 times 3? Plus 10. So 55 would be about there. What's 15 times 4? Plus 10. So now 70 is about there. How about 15 times 5 plus 10? Now we might need our calculators. Those numbers getting up there. Plus 10, remember? So now we're at 85, which is about here. And last but not least, 15 times 6 plus 10. 100, which would be right here. How's everybody doing with my points? Do you see how I plugged them in to find the points if I couldn't do my rise over run? Okay, so now that I have that, question C says, find the total number of pages written after 5 months. How am I going to do that? You already know the answer, you just have to look at it. Look at the 5 months, and folks, isn't this 5 months right here? Yes? So how many pages did I write? Wasn't that 85 when we plugged it in? So the answer to this would be 85 pages. Let me ask you this. How many months does it take me to write 40 pages? How many months does it take me to write 40 pages? Just 2. Did everybody see this 40 pages over here? If I go over, that is 2 months. See how that works? How many pages can I write in 6 months? 100. How many months does it take me to write 70 pages? 70 would be right about here. 4 months. See how you can do some follow-up questions after you have the graph? The graph makes it very easy to answer those questions. All right, let's go ahead and flip over to the back, please. Not really sure why all these lines are on here. Yeah, you will. Okay, here we go. Oh, that's still the same one. What is going on here? All right, a construction crew needs to rent a trench digger for up to a week. An equipment rental company charges $40 per day. Oh, go ahead. Yeah, go ahead. Go ahead. $40 per day. Nope, just go. You're good. Okay. Okay, where was I at? An equipment rental company charges $40 per day plus a $20 non-refundable insurance cost to rent a trench digger. Write and graph an equation to find the total cost to rent the trench digger for D days. Okay, I told you, I want to know where I begin first. What does this cost me right out the gate? $20. So that's my B on the end. What else am I charged? A day, right? Do they tell me a variable to use for days? So how are you going to represent that? 40D equals, do they tell me the other variable to use? What do you want to use? Yeah, I'd use Y too because that would normally be off by itself, wouldn't it? Okay, on my graph, where should I begin? 20 on the Y-axis. Do you want to wait till it stops bleeding? You don't have to stay in here and let it bleed. Are you sure? Does everybody see why I started at 20 right there? Where am I going to go from there? Guys, where am I going to go from there? Not up 20. Yeah, you guys all see the slope there? That slope is 40, isn't it? Okay, so I'm supposed to go up 40 over 1? Oh, well, this is nice, isn't it? That is going up 40, right? So over 1. So do I need to be plugging in like I did on that last problem? No. All of the lines work out exactly how I want them to, and I keep going up 40 over 1. Because my lines on the y-axis actually do go by 40, which is perfect. Up 40 over 1, up 40 over 1. Okay, now I got a couple of follow-up questions for you. My first follow-up question is, how much does it cost to rent for 6 days? For 6 days. You guys see how it's 260 because my 6 days is here? And it's 260, right? How many days can I rent it for $300? It'd be 7 days, 1 full week. Make sense? What if I asked you how much it would cost me to rent this thing for 2 weeks? Is that on my graph? How many days is 2 weeks? 14, isn't it? It would not be 600 because I'm going to take that 14 and I'm going to plug it in there for D. Grab your calculator. Plug that 14 days in there for D. And what do you get? You get $580. Does that make sense for everybody? Now, I want to show you, though, what Savannah tried to do. Savannah found a week, which was right here, right? How much does it cost me for a week? And she just tried to double it. And that would give me 600, wouldn't it? But didn't we just decide the answer was 580? Because if you double that, Savannah, you pay your insurance twice. Do I need to pay that $20 insurance twice? No, just once. That's why it's the 580. So I like the thought. It's a good thought. But make sure nobody wants to pay any extra money, right? Unless you got it, I suppose. All right, moving on. I want you to read this question to yourself. And I don't want you to be scared off by the big words. Because quite honestly, I don't care much about the words as long as you know what the numbers mean. Okay, so go ahead and read that top paragraph to yourself. What two numbers do I really want to be looking at here? This and this. Okay, that's all I really need to know. Let's look at part A. It says write an equation in slope-intercept form. Now you guys know that's y equals mx plus b, right? For this energy. Okay, well I need to know where I start. So looking at those two numbers there, which number is the starting number and which one is the slope? And tell me why. Go ahead. Folks, she says this because doesn't this say in 2002? Isn't that my starting year, 2002? Okay, so that is my B, which is 6.07. All right, so then what's my slope? Guys, is this energy going up or down? So that's going to be positive, isn't it? 0.17 x. Oh, wait, am I supposed to use x? I'm supposed to use p and y. So which one goes here, p or y? Do you guys see how it says increase by 0.17 per year? So the y goes on the 0.17, the p goes off by itself. Are you okay with that, Tyler, or no? It's the same thing that's on your pager. Is that okay? That's all right. All right, now it says now I don't have a graph to look at this time, do I? But if I have an equation, I can always plug into that equation, correct? Approximately how much renewable energy power was produced in 2005. Now here's the kicker. I'm not going to plug in 2005. That's an enormous number for energy to put in here, right? You see how it says year Y between 2002 and 2005? How many years after 2002 is this? 3 years. So I'm going to plug in 3. It's going to be 0.17 times 3 plus 6.07. Does everybody see that? So how much renewable energy would be produced in 2005? 6.58. Can I get a second on that? Yeah? And this is quadrillion BTUs. So really, this is an awfully big number, right? Quadrillion? Okay. Is that okay? One last question. You see this one down here? Read it to yourself. Read that part C to yourself there. What year is that trying to calculate for? What year is part C? How much will be produced in the year? You guys see how it's talking about 2010? Was it my starting year 2002? So how many years after 2002 is 2010? 8. So I'm going to plug in an 8. So what was it, 0.17? What was it, 6.07? Do I remember that right? So what do you get there? 7.43. And remember, this is quadrillion BTUs. So do you see how we had to use the year they started in and figure out how many years went by to plug in? Okay. Quadrillion. All right, I think I got one more over there before I get down to the bottom, right? We are talking about your heart rate. All right, follow along, please. The ideal maximum heart rate for a 25-year-old exercising to burn fat is 117 beats per minute. So if you are 25 years old and your goal is to burn fat, your maximum heart rate should be 117 beats per minute. For every 5 years older than 25, that ideal rate drops 3 beats per minute. Write a linear equation to find the ideal maximum heart rate for anyone over 25 who is exercising to burn fat. Now, folks, go ahead. At the time that this book was written, it was real. They put factual information in your textbooks. Definitely wouldn't apply to any of you because none of you are 25, right? Yeah. Okay, that's okay. So, folks, do they tell me the variables to use here? So is it okay if I choose X and Y? Yeah? Okay, so I'm going to do that. I'm going to say Y equals, I'm going to leave a blank, then X, and then I need a plus a B, right? So I need to know what the starting heart rate is for this situation. You guys see why I put that 117 off by itself? Because that's where you begin. That is a starting heart rate. Now, what happens to your heart rate as you get older? Down, which means what do I need to make this? -3 every 5 years, correct? Do you guys see that? Every 5 years? Now that's important because I'm going to ask you a follow-up question now that I have this. I want to know the ideal heart rate for somebody who is 40. So I ask you, are you going to plug in 40? No, because every 5 years it drops, correct? So how many 5 years over 25 are we? 25, 30, 35, 40. So that's 3 sets of 5 years higher, isn't it? So what am I going to plug in? 3. Okay, so take your 3 and put it in there. Take your 3 and put it in there. 108. So if somebody that is 40 years old that is exercising should have a heart rate of 108. Do you see how we had to take into consideration that every 5 years older? Yeah, you got to make sure you read carefully there. And I think that just leaves me with the graphs at the bottom, right? Yes? We're going to start at the end and we're going to work our way backwards. Okay? Folks, what is different about the first one versus the last two? Yeah, do you guys see how this one is N and G? You all see that? This is a real life situation. Whereas this and this, those are just graphs, aren't they? Of random points. Agreed? Now, what do your directions say to do? Write the equation of each line. What form do you think it's going to be in? Okay, so I am going to go ahead and write down y equals mx plus b under both of these last two. And I got to fill in the m and I got to fill in the b. The easiest one to find is the b, folks, because the b is the y-intercept. So on this last one over here, where does this thing cross the y-axis? What's that? Where does it cross the y-axis? No. Yeah, Sarah's right on. You guys see this right here? Didn't I say we were working backwards? Or maybe I didn't. I don't know. Yes, we're going to go backwards. Okay. So this -3 is the b, folks. Now I got to find my slope. Well, to find my slope, I got to have 2 points, don't I? Well, looky there. We got 2 points, right? I just need to count the rise over run. Do I start on the left or on the right? The left. How many do I need to rise? How many do I need to run? So that is 4 over 2. What is 4 over 2? 2. And do you see how I just plugged in the m and the b into that form? Everybody see that? Didn't the x and the y stay right where they were? Okay, let's do it again. Can you find me the b for this graph? 2, right here. It crosses the y-axis at 2. Now I need my slope. You gotta go, what's that? Down 6, which is gonna be negative 6, which is what? Negative 3. And remember, your x gets attached to that, and it's equal to y. You just have to fill in the 2 pieces of information that you need. Now, it gets a little bit harder in a real-life situation like that first one there. Does everybody see how it's like decimals and all that? Yeah? It's still easiest to find the b. Can you tell me what the b is in this problem? You guys see this b would be right here, wouldn't it? The y-intercept. Can I say that's 2.6? Okay, so that'll be a plus 2.6 on the end. Now I need my slope. Well, for slope, I need to have 2 points, don't I? I got 1 point right here for my y-intercept. Do you see another nice point? 7, 3 is right here. Everybody okay there? Now be careful because I need to count my rise. How much do we rise from here to here? Not 0.5. Didn't we say that was 0.6? Up to 3, isn't that 0.4, folks? How many do I need to run? 7. Folks, divide that. I don't want a decimal inside of a fraction. That looks silly. Divide it. Can that be turned into a fraction? Use your calculator and turn it into a fraction. It should be 2 over 35. Did you do 0.4 divided by 7? Guys, calculators. 0.4 divided by 7. And now turn it into a fraction. It should be 2/35. And that has an x on it, doesn't it? Is equal to... Now really, I shouldn't have used y and x in this problem. What variables am I supposed to be using? N is going to be here. And what's going to be over here? See up here is G is going to be over there. Awesome. All right. What's that? Yep, that'll work. You have a worksheet for homework tonight, so I'm going to pass that out to you now, and you can get started on that before you leave. They should. You guys would be the future of the program someday.